3 in Chang is really about going from a physical database design, that's what we did in Chapter 2 in Chang, and getting that physical database design into Microsoft Access or any other relational database system, but we're using Microsoft Access. And we'll talk about the three of the four primary objects in Microsoft Access. First of all, the fourth and the most important is probably tables themselves. But Microsoft Access also has objects called forms, queries, and reports. And let's get to it. We'll understand those objects, and actually we'll mention three others. We'll talk about how do you create tables from a data model, right? You have your physical data design, and how do you get to creating tables. We'll talk about it. It's going to be much more interesting when you do it, so we'll get to do it. We may do it on Monday. Once you've created the tables, you have to create the relationships between tables. We'll see how to do that on Microsoft Access. And then we'll learn how to create forms, and forms are exactly what they sound like. They are the object that allows you to enter data into a table. We'll talk about creating reports, which are what you look at, and we'll talk a lot about queries. Queries are a lot more interesting than just being some way to get ad hoc information. And then practice, 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 you will get online and start working with Microsoft Access. And the next about 4 weeks of your life as it relates to this class will be that. So there are 7 object types in Microsoft Access. I mentioned the primary 4 already. There are 3 others. I've graded them out because we're not going to focus on them in this class. Pages, macros, and modules. A page is something that you could use on the internet. A macro is a very small app that could do a very specific function. Like it create a button that will allow you to submit data. So that's a macro. A module is a larger app that is not written in the 4th generation language which Microsoft Access provides. Tables are exactly what you think. That is where you store your data. They're analogous to a file. So all of your data is contained in a table, some table. Now you can have a lot of tables because you can have lots of different information. You might have a customer table, a sales order table, an item table, a sales order item table. Queries. It allows you to ask questions. So essentially what a query does, you ask a question using SQL essentially to the tables, and it brings back some subset of data that is a correct answer to that query. That subset of data is called a dynaset. Now in its simplest form, a select query just displays that data. But queries can do a lot more than simply display what you've requested. And we'll go through a list of some of those things that it can do. It can do things like combine data. You can do a query and say, I want to combine data from 2 different tables into a single table. It can perform calculations for you. And it can do searching, selecting. Forms. Think about a form you fill out by hand. A form is a means of getting data into a table or multiple tables. A form, because it's online, can be created in a view that is appropriate for a specific user. If you think about it in terms of what we talked about in Chapter 4, just with the client-server architecture, the form is what would be the presentation layer and might very well be on the client side of a client-server architected environment. In its simplest case, a form might just be a copy of a paper-based form. However, because it's on the computer, it is online in real time. You enter the data in, and it's there. You guys will be creating forms, I hope. Reports. Reports are, think about a paper-based report that you get, except they can be either paper-based or on the screen. There's no data entry at all in a report. If you've created a report and you're able to enter data, you've done something wrong. So it can be online or printed. So when you create your reports, you're thinking about, if this were to be printed, where are the page breaks and how is it going to look? And it could be used for a variety of purposes, creating invoices or purchase orders, sales summaries, financial statements, etc. Okay, the three that we're not going to focus on: pages. So that'll handle data from the internet, as we said. Macros. Generally, I think about them as a button of some kind, some way to simplify the user experience on a form or a report. Some students, when they do phase 3 of our project here, use macros to do things like create security. So like before you can get into the system that you'll build, you create a macro that asks for a user ID and password. Modules use a different language like Visual Basic or C++ or something like that to create actual program coding that's more complicated than the program coding you can do in the Microsoft Access. And then they would link into Microsoft Access for use. Think about how to, kind of the step 9 of the process, which is creating a database, a physical database. So you do steps 1 through 7, which is your logical design. Then you do your physical design, which was kind of chapter 2. Then you define your tables from the physical design. You define each attribute or field. You identify the primary key, any foreign keys. You establish the metadata, the input controls, any rules that you might have related to it. Then you would create your forms to get the data in, the forms for maintaining your tables, and any queries and reports for reporting information out. And those are the steps of creating a system. So you start off with some kind of an ER diagram. This is the ER diagram we've seen before for course offerings and professors and students and registrations. From there, you'd also have your DFD. This is the level 0 DFD. You do your physical database design. This is what you're going to do in phase 2 of your project. Something like this, with tables and primary keys and foreign keys and other non-key attributes all lined up. Here's an example of a relationship table with a concatenated key. You would then actually take your tables and you'd start to enter them into Microsoft Access. And this is a screen that you'll see in Microsoft Access. It's the metadata for the item number field. You can't read it here, I know, but that's the item number field. That's the primary key in Microsoft Access. This thing that you can't see over there is a key that tells you that it's the primary key. And down here is all the information. Is it required? This one says no, but you're going to change this to yes because the primary key is required. Notice there's a field size key for any field that is a text style field, and this one is defined as text. This field size can be very, very large. You can make it 256 characters. It's going to default to like 255 characters, I believe. It is bad design to keep it that big. You make the field size appropriate for that field. So if you know that your item number is a 10-digit code, you make your field size 10. You don't want people to be able to put in the wrong size field. Plus, you make the field size smaller so you don't waste space on your disk. Even though it might just take the stuff at the end, which is just blanks, and condense it in some way, it's bad disk management to have your fields be larger than they should be. You don't want to make things slower and sloppier. So field size should be as short as it can be and still get the job done. So you would define your fields. When you're done defining all your tables, you're going to get to a screen like this in Microsoft Access, which is your relationship screen. This is where you relate your various tables to each other. This is a 1 sign, or the number 1 there. That's an infinity. That's a sideways 8. That says that this is a 1-to-n relationship. Notice there are no many infinity to infinity relationships, because what you will have is a table like this, which is your relationship table, that has 2 one-to-many relationships, 1-to-many here and 1-to-many here. That creates the many-to-many. That's what a relationship table does. So that's your many-to-many relationship. If you see something like this, where you don't have a 1-to-many, you've done something wrong. This is a mistake. There should always be a 1-to-many or possibly a 1-to-1, but you're not going to see many of those. If you see a situation where there's nothing, that's a mistake. This is not a problem here. This is just the line is going behind. It's going behind the tables. But this is a mistake over there that it would need to be fixed. These two fields were probably not defined in the same way. Remember, a foreign key needs to have the same field format as the primary key that it relates to. So you'd create the relationship between your tables. You would then use this mask, or a mask similar to this, which you can't see here, to actually enter your test data. You could actually enter test data outside of a form to test your system. You'll see how to do that. Don't worry about that. You might create some forms. Notice a form is in some way structured, so it makes it easy for the end user to get through the process. It might have some fields that are preset, or if you enter information into the offering number, it might enter some other information. The instructor is Pat Benatar. But notice also that a form could have a list in it, because this is a form that allows you to essentially implement a 1-to-many relationship. One registration could be for many classes. And so you'd keep entering all your classes that you're registering for. Then you'd have these forms that are maintenance forms. So the student record. Let's say the student changes their address. You'd come into this form and you'd change the student's address. A report is an output. Kind of looks very different than a form. Visualize this being printed out. This would be like a pay stub. Or in this case, this might actually be a check that you're printing out with the information above it. So it's very formatted. You need to think about page breaks and the prettiness of it as it's going out for the world to see. So you can see it online or on paper. That's a report. And a query, which we'll talk about in a moment, is very ad hoc. It doesn't have that prettiness to it. Some guidelines. Do your designs first. So when you're doing phase 3 and you're building a system for us, design first, implement later. Otherwise, you'll be implementing many, many times and fixing lots and lots of bugs. Naming conventions. Access is pretty liberal about how you name, but there are certain things that we will strongly recommend to you. First of all, no blanks in a name. A name should just be a continuation. So think if you have customer number. Think of all the different ways you could do like the name customer number. You could have that. You could have
cust number, cust ID. Choose one, and then make all of your primary keys one of these. Be consistent in the way you do your naming conventions, so that you don't have to think, oh, I forget, did I name it customer number, or was I calling it? You know, always do it the same kind of way. Probably not this way, it's too much typing. And use mnemonics. Everybody remembers what a mnemonic is, right? It's when you have a coding scheme. A mnemonic is a coding scheme. I can just look at this and say, oh, that's the customer number. It should be meaningful. It shouldn't be, random letters or random numbers as you name a field. Be thoughtful about your data, your metadata. Correct data types. Remember that foreign keys have to have the same data type as the field that they're, the primary key that they're matching up to. Limit the size of the field. We talked about that. It should be only as long as it needs to be to get the job done. And then there are things like input masks, which we're going to learn about, I think, today. An input mask would allow you to format, as you go along, the telephone number. You just start typing the number, and it'll put this and that in for you. So it makes sure that you're doing the right thing. So we'll work with input masks, hopefully, today. Let's talk about queries. So we talk about everything except queries. A query, when we think about a query, you're thinking about, I'm asking a question. You're asking the database a question using some SQL type of language and expecting an answer. And that's really the main part of what queries do, but they're also powerful in other ways. What a query does is you go to the database and ask the whole database for some subset of its information, whatever that might be. That's the subschema. The schema is the entire database. The subschema is the information that a query gets back. Now, there are about 10 different kinds of queries. And you could do, when you get this subschema back, you could do different things to the data based upon what type of query you've done. The most common type of query is a select query, which we'll see in a moment, which says, I want to go to the database, I want to ask it for certain information, and I just want to display it. You're selecting it and displaying it. That's a select query. But there are others as well. So a dynaset's another word for that subschema. Here, this is a query request. You want the car registration to be California. A very simple request. You want to go through the entire database, and you want to list out all the cars that are California cars. And that would bring you, in the select query, this very poorly formatted kind of, it looks nothing like a report. It's not as powerful as a report. Just a listing of everybody with a license plate of California, because that's what you asked for. That's a select query. Select queries could also be off of multiple tables. That was just, you go to one table, get everything from California. You have 3 different tables here. You want data from those 3 different tables that are linked together on their database, and you want to display all of that in a single query. You can do that as well. And it would be a list of, it looks kind of the same, but you actually pulled that data from 3 different tables. Other types of queries, and you'll do a lot of these as well, are parameter queries. A parameter query, you actually would have a pop-up box at the beginning of the query experience you create that says, let's say I want to see all the sales after January 1st, 2015. So it allows you to dynamically define the characteristics of the query. You don't have to create the query once and then recreate it every time you want to create a new query. All you do is enter some data into a pop-up box, and that will bring back only those sales after that date. Or you could have only sales above a certain amount of money. Whatever the parameter that you want to define dynamically is. That's a parameter query, which you will also do quite a bit of. Then there are these things called action queries. These action queries not only display data, but they actually do things to the data. A cross-tab query does statistical analyses. So it pulls back the data and creates an average for you. A find duplicates query does exactly what the name sounds like. It looks for duplicates on a certain field. Maybe there was a sense that I talked about early in the semester that SSN, Social Security numbers, are not actually unique. So you want to see if you have duplicate SSNs in your file. You could do a find duplicate query for that. A find unmatched query. This is if you don't have referential integrity. You're looking for situations where your foreign key does not match up to an appropriate primary key. A delete query, exactly what it sounds like. Maybe you want to kind of clean your database up, as we all do to our files every once in a while. Let's delete all employees who left the company more than 10 years ago. An append query. You will do append queries in this class, where you want to take information from one table and add it on to another table. We will use this to create reports. Queries are your basis for creating reports. You do a query to get the information, and then you format the report very nicely off of the information that you got from the query. Sum column query, guess we know what that does. It sums a column. An update query, let's say you want to increase all your prices by 10%. You can use a query to actually go into the database and change your price field and increase it by 10% across the board. A make table query is used for archiving data. So let's say you didn't really want to delete all those old employees. You want to pull them out, and you want to create a new table for them, which is an archival table that you'll then send to Utah to stick in the mountain that you don't have to think about. But you don't want to truly delete them from your records. So you'd make a table for all your older employees. Okay, so those are the various kinds of queries. Queries are very powerful in a relational database. They use SQL. We saw some SQL early in the semester. We're not going to get too deeply into it. I may, when we get into Microsoft Access, just show you that it actually generates SQL statements from the work that you do. You can do data mining from data warehouses. So data mining is the process of getting information out of a data warehouse or a data mart. You could extract data. You could look for relationships between data. You can use pivot tables. I think I asked that before, and some of you have used pivot tables before in Excel. And it's the same idea in Access. This would be an example of a pivot table. It does summaries and then sub-summaries. It just kind of brings the data to life a little bit. Forms. Not going to, there's no better way to really understand this than getting online and doing it. So I'm going to run through these quickly. You can design a form. Sometimes if companies, they had a paper-based form, they just create a form online that looked like the paper-based form. It's kind of what this looks like, but you do it with some formatting that makes sense. As you create forms, it matters what it looks like. You want to be professional. In your project, you're going to view yourself as, let's say, a management consultant who's giving a product to a customer, to a client. You want it to look good. There's a wizard. We'll go through the wizard. Don't worry about it. As you create your forms, you'll see how you can toggle between running it and designing it, and running it and designing it, so you see what it looks like as you go and make improvements as you go. I guarantee you're going to be frustrated. I guarantee it. Not everybody, but almost everybody in this room is going to be frustrated. You're going to blame the computer. Remember that forms could have subforms where you can enter lists of data. Reports, only for output. So if you create a report and you can do data entry, you did something wrong. Reports have headers and page headers and group headers and detail lines, and this is going to be a source of angst, getting everything in the right section of the report.